G'day Bifrosters, we're back again in the logic series. Well, this is the second video, so I'm not sure if it's a series just yet. This follows on from the introduction to logic video, where, if you remember, we went in here, we talked about AND nodes. This was checking to see if these two vectors are equal, if both the x's, the y's, and the z's are equal. So x is equal, y is equal, z is equal. Then if all of those are equal, the two vectors are equal. That's an and that's an and. So we've already been through that. What we're going to do today is OR. We're going to do an OR. So for that, what we'll do is we'll start working with maybe some colors. So I'm going to really quickly points in a sphere. So let's unplug this from the output so we don't get confused. So I'm just going to make, this is a node I've made to generate points in a sphere. It's handy. When I do my custom node video, I'll probably go through it. I'm going to construct a point object, plug the positions into it, then I'm going to set the color of those points. So that's a set geo property, and let's just get our parameter editor back, and what we want is color. It could be anything you like, but color will show up on the display, which is what we want. And this data needs to be a math float 4, which is what we're going to be performing our logic on today. If we pop that out, I have a lot of points. If I really want to see that color, I should probably put in a point scope. Pop in a point scope there. It's going to break that. Put that back together. Lovely. Go to the point scope. All I've got to really do is change the coloring property to color. So when you're working with colors, they're float 4s, well, they're vector 4s, which is red, green, blue, and alpha. And what I want to do is I want to set some colors in here that we're going to use for our logic later. So I am going to put down a couple of value nodes. That's not what I wanted to do. Thank you very much. And I'm going to make this value node a vector 4 floating point, which is cool. And these will become our colors. And let's get some reds, and I'll copy this and paste it 3 or 4 times. We'll get some reds, we'll get a nice orange, and we will get a blue and a green, and maybe something in between blue and green, so some green, some blue. So now we have 5 colors. And what I'm going to do is I'm going to use just a little bit of random to choose between these. I'm going to put these into an array by using build array. So I'm going to end up with an array of colors. And we're going to use some of Bifrost's array functionality to randomly pick one of those colors from that array. So to do that, I'm going to need a get from array. And I need to find some way of taking these positions and generating, for each of these positions, I need to generate a number between 0 and 4. So we'll take these positions out just as a great big loop, because Bifrost will loop through them intrinsically. What we're going to do is we're going to generate here, we're going to generate a random value array the same size as these positions. The seed can be any number you like, it just changes the way the random value is looked up, and the offset is what we want to work on at the moment. So at the moment it's a number between 1 and 0, or 0 and 1. And we can work with that because we know that 1 divided by 5 is 0.2. So let's go in here and make our first piece of logic. We'll just make a compound to keep things tidy and to increase my spelling. We've got the random values coming in. What we're also going to need, well, what we're going to need to do is get an index out. So we need these numbers coming in and an index as a long coming out. So here's our random values. we're going to do less. So if our value coming in is less than 0.2, then our output, this output is true, and we'll go and put an if statement. So if this is true, our true case becomes a value that is of type long, which is, and there we are, see the type down there, integer of 64 bits long, which is what Bifrost kind of likes to do for its arrays. Its array indices anyway, and we'll pop that into the true case. And that's great. So now we just need to do that a few more times, because we have 5 different values. So this one is going to be less than 0.4. And here's where the logic comes in, because this is less than 0.2 and this is less than 0.4. I'll get rid of this for the moment. So if this random value that we generated outside of the compound is 0.19, it's going to be true for both of these. So we need to go back and use our AND statement again. We need to pop this into a greater. So what I'm telling this is that I need you, if you are less than 0.4 and greater than 0.2, so put in an AND statement. So now this will return true only when these two are true. So if the value is less than 0.4 and greater than 0.2, then send out a true. And then again we put in our if. And the condition, please. And we'll grab this guy, copy and paste him down here, make him a 1, put that into the true case. And here's another logic thing. What I can do then is chain that into the false case. So now what this is saying is that if it's less than 0.2, which is, that means that is true, then output this one, output that, the true case. If it's not, then the false case goes off and it checks to see if it's in this range, and if that's true, that'll come through in here. And what we're going to do is end up chaining all 5 of these up and then throwing it out to the output. So let's get on with that. It might take a little while. I hope not. We have all the logic sorted now, so pop that down there, lay it out. And this one, it needs to be less than 0.6 and greater than 0.4. And then our end statement's the same. This we need to change to 2. This is our output. And then I'll move everything over a little bit and chain up our logic again. Paste again, make the changes we need to make. So first off, I'm going to change that to 3. This is less than, what did I say before, 0.6, so this is less than 0.8 and greater than 0.4. And we'll get rid of that because that's not what we want right now. What we want right now is move this guy across here and this one over here. I'll chain that up again, and then last one, if it's less than 1 and greater than 0.8, we're going to output 4, which is our index that'll be coming out. That gets plugged into there. Okay, so I've screwed up my logic somewhere. That happens too. Let's just break all these false connections and run through it again. So this one should go into here. So, and then this one should go into here. Where am I getting my logic conundrum? That seems to be better now. Now we just have one thing left to do, and I've done this done this deliberately. You've noticed I've just used less and greater. There are two other nodes, less or equal, greater or equal. And what this is saying, if I was going to do this a bit more formally, every one of these less thans would be less than or equal, be these guys. Because at the moment, if the value, the random value coming in is exactly 0.2 or 0.4 or 0.6, these aren't going to trip. They're not going to become true. So what we have down the bottom here is we have a last empty false case. And all I'm going to do for that is I'm going to say, look, if there's anything else that you're picking up that isn't falling, it's just falling straight through the logic, make it a 0. So now we can put out our output, and this is going to be the index of the color array that we choose, like this. So here's our color array, 0, 1, 2, 3, 4. Up here we have 0 and 1, 2, 3, 4, and then 0 again. So this plugs into the index, so you get whatever index this is telling you, and then we plug this into the data. And there you are. You have a randomly chosen one of 5 colors. And we managed to have a quick, we managed to do a quick bit of logic using ands again. So that's a nice refresher as well. Okay, so color array, let's pop this into a compound to make things just a bit tidier. We'll call it color array. And of course, just like anything else, if you wanted to come in here, just lay it out so you can see it. If you wanted to have the ability to if you wanted to have the ability to customize those colors, you could just plug these values straight into the input, and you'd be able to go up. You can see you'd be able to change that color there. But I'm not going to do that. I'm happy with what we've got. And it's my video tutorial, so I get to make decisions like that. So here we are with each of these points has now a color. Well, let's just get the last video's results out of the way for a second. Each of these points has one of 5 colors that we have specified in this color array. And we did that by generating a random number between 0 and 1. And then inside our chooser compound, we know that 1 divided by 5, there are 5 colors. We know that 1 divided by 5 is 0.2. So we just did a check for 0.2, 0.4, 0.6, 0.8, and 1. And that gives us 5 colors because we also put in this protection here, because we'll be talking about less or equal and greater than or equal in a different video. I could have done it here, but to be honest, I just forgot. Hey, teachable moment. So now we can get on to talking about the logic. And I'm going to do that. What I'm going to do is an OR. We're going to do an OR logic, which is very similar to AND, except it's not AND, it's OR. So what happens if I want to change every single red one and every single blue one into, let's say, a white one? We're getting the color property. Now we have another array. All of this has happened. We set the color, and then out here we're going to set the color. We're going to change the colors again. We have an array that's simply spitting out the colors that these are applying to. We could just do it here as well. You can bypass this entire step, but I wanted to show you how this worked as well. So we're going to make another compound. And while we're at this, we should change the name of that one. Should change the name of that one. This one, we're going to call replace colors. Let's jump in and get going. So just so we keep in our minds what we're doing, what we have here is an array of all of these points. So if I go size, my array size, remember we had 5 colors, and I'm going to output the size, and then I'm going to throw that size into the output. so we can throw a watch point on it, like so. You have 1500 things in this array, which if we go back to my points in a sphere, you'll see there's 1500 points there. If I change that to 2000, there's 2000 points now. And this is 2000. So what we have here is an array with 2000 things in it, each containing some colors. Now I have it black in there somewhere because my minimum is showing up as black. So that's kind of cool. We'll have to go and find that later. Okay, so what I want to do is I want to get those colors and I want to do an equal. Now we run into the same problem that we did earlier where we can't do an equal on a vector. And we set up a way to do equal on a vector in the last video. So I'm just going to go up here. I'm going to grab this, which is the node we made last time. We'll paste that in there. So I want to find two values. I want to find, these have to be vector 4s. Like so. I want to find red. And I want to find blue. So just vector is equal is not quite going to work for this, because these, when we set this up, if you have a look down the bottom there, these are float 3s and these are float 4s. So there's two ways we can do this. We can jump in here and add another piece of logic so that these become vector 4s, vector 4 to scalars, and then we'd have a fourth object here, which would be W, and we add another one of these, and we add another one of these. But because we're not using our alpha channels at the moment, we could get away with converting these to vector 3 and then adding the alpha channel back on later. So I'm going to do that just for speed, but just be aware that this would be very, very simple to change. You'd have to add one more of those and one more of those, and then you'd have to just do the comparison and then tack that on the end. So I'm going to go about it the easy way by taking vector 4, by just lopping off that W. And I'll put that back on at the end. So now what we've got coming out of here is 1, 0, 0 and 0, 0, 1. And these, quite apart from any logic, don't go in here. What we want to do is we want to see if this vector, and we have an issue here. This is also a float 4. You see how this is telling me that internal graphs have one node has messages, and in here this is basically saying it's a vector 4. I can't do a vector 3 to scalar on it. Let's break that, move that. We just need one more of these. Because again, we're not using any of the alpha channel information in this example, so we can just get away with turning this into a vector 3. So that goes in there, and that goes in there. Now in the last example we did two vectors, and we spat out whether they were equal or not. Now we're putting in one vector and one array of vectors, so our output will be an array. It's an array of trues or falses, and I can show you that by popping that in the output and then popping that output out in there, which again from last video may not work. It did this time. So this is the size of 2000. The minimum is false, the maximum is true. If those were both false or both true, something would be wrong, but it's saying there are false ones and there are true ones, which is great. That's what we want. And we'll set this up for the second one as well. We'll just leave the same one. We'll just put this as an array in v3, so we know what we're doing. This time we just need to change vector 2 to our second vector, and again we have an arrays of true or falses. So what I said we would do is we would change anything that was red and anything that was blue into white. So what I need to do now is run some logic. I could try using AND, but that would say if it is red and it is blue, turn it white. What I want to do is say if it is red or it is blue, make it white. So we're going to use the OR statement here. And it just does what it sounds like. It's if that value or that value are true, this will be true. If both are true, they will be true. If both are false, so if whatever this color is does not equal red and does not equal blue, and there's a lot of them that don't equal red or blue, then this will pop out as false. Exactly what we want. However, what we've got right now, which is, I'll just delete that, is giving us a bit of trouble, is we don't have which ones anymore. We just have like, this is coming in, is it true, is it false? We don't actually have which colors are coming through to help us. So it's a little hard to change that in the array without knowing where it is in the array. So if we just have a look at that, still false, still true, but we still have the same number of things in the array, 2000. And because Bifrost preserves the order of arrays, this is an array of trues and falses that's in the same order as this. So literally, all we have to do is say, if this OR statement is true, which means it's red or blue, either one, so if that's true, no, we don't even have to do that, my bad. All we have to do is find all in array. Now, if you have a look at the find all in array, you've got an array coming in, a value, and an invert. So this goes through the whole array and it looks for this value. And when it finds it, it puts out the index of that value. And that value right there, because the input here is Boolean, this is looking for a Boolean value. It's looking for either true or false. You see, so when that's on, it's true, and when that is off, it's false. And if I could click invert, and it would reverse that value as well, but we'll leave that alone. It's pretty self-explanatory. So with one node, what I have is all of the indices in which this statement is true. And all I need to do now, I'll need one more color, which is our replacement color. And we said we'd make them white, so let's do that. Lovely. Here is my array. Ah, that's right, we were doing vector 3s, weren't we? I can't forget that because that'll trip me up. We'll just change that to a vector 3 because remember we cut off the alpha here. We have to make sure that we put that back on later, but actually I'm incorrect. We can do it with the vector 4s because even though we're comparing the vector 3s, we still have the vector 4 array and it's still in the same order. So all I have to do now is grab this input array and we go, I think it's, nope, set an array, I believe. Yeah, set an array. So that's the array where we want to set values. Here's the indexes or the indices that we want to set, and here is our new value. So let's just delete these. Yes, I know. I'll delete that one too. And we'll pop that out. So now we've got all 5 colors coming in. We're changing them into vector 3s. We've got 2 colors we want to find, which we're also changing into vector 3s. Where they're saying, is that vector equal? And is that vector equal? If either one of those is true, find everything in the array that's true. So this is our true or false stream here. Find everything in that array that is true and set it in the color array, and this is the vector 4 color array here. Set it to white and then output that. So it's outputting the same array. I'll have the same length here when I hook that up. I'll have the same length here. It'll still be 2000 things long. It's just replaced values in the array with these ones at these indices. Alright, so here's our replace colors. What we'll need to do is another set geo property. Drop that in there. Drop this in here. Make that color. And then drop that in there. And you can see that everything that was red and everything that was blue went white. So let's quickly recap that, because I really didn't want to spend too much time on this. We made some points in a sphere. We constructed them, and then we made an array of colors. In this case, there were 5 colors. We then made a random value array that spat out a different random number between 0 and 1 for each of our points, in which case we have 2000. This then chooses that color in here, less and greater than. Okay, so very quickly, if it's less than 0.4 and greater than 0.2, that becomes true, and this is what gets put out, and we're using 1. So we're essentially just assigning a number between 0 and 4 randomly for every point in this array. Then I went, well, this is where it chooses the colors. It gets those from this array, because this array has indices of 0, 1, 2, 3, 4. Now we have an array of 2000 that we set to the color, and what I will do, I will very, very quickly just throw in a quick if so we can switch between these and take a look. So move that out of the way. That becomes the true, and that becomes the false. I drop that in there. So at this point, we're about here. We've set a random color to each point based on 5 colors we set up. That's great. And then I went and got that color property back out, and I replaced the colors. So in here, what I've done is I've gone, here is an array of colors coming in. You can add a watch point to have a look at it. It's not hitting that right now. Let's turn that on. So it's hitting it. And you can see that these are vector 4, 0, 0, 0, 1. 4 things, it's a vector, 0, 0, 0, 1. What I've done here is I've converted that to a vector 3. So if I take a look at this stream here, 0, 0, 0, 1, 1, 1. Because I know that we're not going to be doing anything to the alpha channels, so to enable the use of the vector as equal node we made last time, I've turned these into vector 3s. I will show you later on how to turn this into a node that takes any kind of vector and still does the comparison. I'm fairly sure that's possible. I guess we'll find out together. So this is now delivering a true or false based on whether the vector coming in the array is the same as this vector that we converted to a vector 3, which in this case is 1, 0, 0. It's red. X is red. Y is green, Z is blue in this case. So this is the red one. Is it red? Is it red? Yes or no? Puts out the true or false statement. And here is the blue. Is it blue? Yes or no? And I'm saying if that is red or blue, this will become true and becomes a 2000 point array. It's the same size as everything coming in. There it is. And some of them are false and some of them are true. This node finds the value, the true value, because that is switched on, and gives me back the indices in this array where that is true, where it's found this value, and the value being true. And then I go all the way back here to this is once more the vector 4 array, which is what I mean by when I say that we were not using the alpha channels really. So it's the same array, it's got 2000 members, same as this. What this is doing is it's inside this array, find these indices and set it to this value. And you know, we should probably put on some alpha channel there as well. So go through this array, find these indices that we used our logic to find, and then change them to this color and output them. And then you get the case where you can replace the reds and the blues with white. red or being the operative word here, red or blue. Now I could jump back into my color array. I could go one. Let's do the same for our oranges, just to show you that it's really quick to do. Go to the replace colors. We'll go into the, instead of the reds, we'll just add 0.5. See, my reds come back, but my oranges go away. So now this is saying if it's orange or blue, make it white. Alright, so that's a real quick explanation of the OR logic. I will keep doing the logic stuff, so we'll go into greater than or equal to, we'll go into OR. We have things like, we can set up logic gates, we have NOT, and we have OR, and that makes NOR together. That's a little bit more complicated, but we do have fairly robust logic in here. I'm not sure if we have a NOR, we don't. We do have an XOR though, which is pretty cool. And feel free to go ahead and explore all this stuff to find out what it does. One but not both of the inputs are true. Alright, so I hope that's helped, and I will see you next time. Thank you very much.